About. Hello everyone. Today we're looking at complex number problems from IB Maths higher level. So we're just going to dive into the problems. I've not seen this before, so we're just going to kind of work through how to solve it together. So this says consider these two complex numbers. We've got 1 plus 2i, v is 2 plus i. Given that 1 over u plus 1 over v is equivalent to 6 root 2 over w, express w in this form. Okay, I mean, I think the logical thing is just to plug that in for now and then see where we go with that. So 1 over 1 plus 2i is 1 over 2 plus i is equivalent to 6 root 2 over w. Okay, and w is what we're solving for. I'm going to look for ways to try and combine these into one structure. But naturally, I'm just thinking it would make sense to rationalize these. That's what the heart wants. So 1 minus 2i, 1 minus 2i on top as well. So this becomes 1 minus 2i over, it would be 1 plus 4, it would be 5, wouldn't it? 5. So that's because it's 1 times 1, 1. The 2i times 1 and the minus 2i times 1 will cancel. And then you'll be left with a minus 4i squared. I squared is minus 1, so that's plus 4. 1 plus 4 is 5. And then we do the same thing over here. 2 minus i, 2 minus i, and then this becomes 4 plus 1. This also becomes 5. Is that right? 4 squared. 2i minus 2i cancels. Negative I squared, that's just 1. So 4 plus 1. Brilliant. Okay. Good news. Root 2. Okay. I am thinking, let's just combine these, but I'm thinking it would make sense to actually write w out at this point in the format that they're looking for. So as a plus bi, just so we have really an idea of what we're solving for. Helpfully, these bases are already the same, so I think it would make sense just to combine these. 3 minus 3i over 5 equals 6 root 2 over a plus bi. I mean, this is kind of screaming to be cross-multiplied, I think. So if we multiply these out, and we go 3 minus 3i, a plus bi equals 30 root 2. Now what this suggests to me is that these must be conjugates in some way, right? Because we're not ending up with a complex number in our solution here. We're suggesting that this expansion would be equivalent to just a real number. I mean, I'm going to expand it fully, but it kind of suggests they're conjugates, doesn't it? So 3a, or something like that, 3a plus 3bi minus 3ai, and then finally minus 3bi squared. So 3a, these two can go together, so we're going to have like this is going to be I squared is minus 1 again, right? So we've got sort of 3a plus 3b. Those are our real components. And then over here, we're saying we're going to have a 3b minus 3a I, and then that's equal to 30 root 2. I mean, this is really interesting. It almost seems like it's not going to work. Maybe we have done something wrong, but we'll find out. So if this is the real component, like if the right-hand side of this equation does not have an imaginary component, that suggests 3a plus 3b is equal to 30 root 2. Like, this is the real component, that's the real component. And then separately, 3b minus 3a must equal naught. But that suggests that b and a are equivalent, which possibly just seems counterintuitive for some reason that they would be the same. I don't know why I think that. Okay, so divide everything by 30. A plus b then, or by 3, sorry. Everything that is 10 root 3. I mean, this suggests, if these are equivalent, that a ought to equal 5 root 2 and b ought to equal 5 root 2. So that would be our complex number. That does feel odd. I don't know why that feels odd to me, but that feels odd. I'm just double checking the working out. 5 times 6 root 2, yes. We've got 1 minus 2 root 2. That does give us 3. It gives us minus 3i. We're over 5. Yeah, I think this is correct. It just seems odd. For some reason, my brain is not happy with this as a solution, but we're going to park the gnawing feeling of doubt for a second and go and have a look at this. So W, let's just store what we think that is, right? So we think W is 5 root 2 plus 5 root 2i, right? Express it in this format. Okay. Well, to be fair, the fact that they're the same would make it much easier to answer this problem, right? So the conjugate of W, I'm just going to draw a division. The conjugate of W, which is what that little star thing represents, that's 5 root 2 minus 5 root 2i, right? What this suggests is if we were to do this on an arc-on diagram, we've got a real component that goes to the right, 5 root 2 from our origin, and then we've got a component that moves down by 5 root 2, and this is our vector. So if we want this in argument modulus form or polar form or whatever you want to call it, we want the angle. This angle should be 45 degrees. It should be pi over 4 because those sides are the same. It's an isosceles triangle. So that would suggest we're looking at it would be negative pi over 4 since we're down, right? Or I could write that, probably better to write it as 7 pi over 4. So that would be written in that formatting. And then based on how our sort of 45-degree triangles normally look, they normally look like 1, 1, root 2, right? So it suggests that we're looking at maybe 10 for this, for the length, if that's correct. I mean, that would make a lot of sense, right? I'm feeling better about our previous answer, given that this has worked out so nicely for 2. It suggests to me that maybe we did get the answer correct, even though for no reason at all I have this feeling that it's somehow wrong. Let me go check the mark scheme to see. No, this is not this problem. Where are we? Here. Okay, yeah, we got it correct. They were useful. They were happy to have minus pi over 4. Okay, it was right. For some reason that felt like it was going to be wrong, but it wasn't. So hopefully this was helpful. This is just really a process of plugging things in and rearranging them, using conjugates where it's appropriate. And then we can always, when we're dealing with complex numbers, because the imaginary axis and the real axis really don't interact with each other, they're kind of incompatible. Whenever we have an equation that's set up like this, where you're setting it equivalent to maybe just a real component, what that's telling you is your imaginary component is 0, it doesn't exist. Because it's a real number, effectively. And that must mean that the real component that you have is equivalent to just the value that's on the other side of the equal sign. So you can set it up like these two simultaneous equations. Hopefully this is helpful. There will be other complex number problems. They're all going to be in a playlist. So if this is helpful, you can go and take a look at those.